Hello all, good morning. Welcome to this meeting where we will be discussing our module 4 concepts. The first and the foremost concept that we are seeing with respect to module 4 is basic principles of analysis and testing strategies. So what do you mean by basic principles? Why you require basic principles? See, whenever I want to point or I want to say a particular software product is a reliable product, I need to have some metrics to be analyzed. So it will be done with respect to the basic principles that we are adapting. So mainly there are two clusters available with respect to basic principles of analysis and testing. First is specific analysis and testing strategies. Second one is generic analysis and testing strategies. In each of the particular cluster, there are three more subdivisions available. First, in the specific type of testing, we will be having uh, sensitivity. Second one is sensitivity will be that, followed by redundancy, followed by restriction. It can be remembered by SRR. This is with respect to specific type of analysis and testing strategies. Whereas with respect to the generic strategies, partition, visibility, and one more thing is feedback. So these are all the six basic principles which is very, very essential for any software product to be uh, saying a reliable one. So just to give an quality, just to give the quality of the software product, you can go with analyzing the six principles. One by one, we'll just see it. So these are all the first. This is how it has been categorized. The main analysis and testing principles will be containing two different strategies. First one, as it has been mentioned, so I'll just say this is my cluster one. That is a specific. This is specific to the software product which we are developing to. Any product which we are developing to, for that it will be uh, given the answer. This is the generic one. This generic one, what it says is it is for all. Whether you develop a product for a um, X company or Y company or Z company or anything or n number of such software products, you can just develop it. Whatever it may be, it may be for educational institution, it may be for a, uh, corporate world, or it may be for any other thing. So these three principles you should not forget it. With any at any cost, you should not forget it. So this is how. So this is our second cluster. So in the first cluster, as we have mentioned, the first one is sensitivity. What is the sensitivity? Better to fail every time rather than once. What do you mean by this? It's a very simple one. See, whenever I say sensitivity at that time, it means to say that it is a consistent enough. Consistency is what is required with respect to the term called as sensitivity here. That means if a person with respect to educational institution, if I am talking about with respect to the education of a student, if I am talking about at that particular point of time, sensitivity is nothing but if a person fails in all the particular if the person is achieving a very good marks in all the semesters, then that person is consistent. In a specific one, if I want to say it means, so if the person consistently scored 60 percentage in all the semesters that he has undergone, or he has taken the exam, he or she has taken the exams, then that person is a consistent. We say that sensitivity is maintained over that. Whereas if the person till the final year, that is till the seventh semester, whatever the exams that he or she has taken, uh, he or she has pursued 60 percentage in all the semesters. But once they enter to the final year in the seventh semester, one particular course has they have scored less marks in one of the course, so that it will be reduced to 40%. They have passed, but they have reduced it to 40%. Then there is a problem in that. So we need to address that particular problem, because till the 6 semesters there was no problem with respect to that person. Once the person reaches to the 7th semester, there is a problem. So which particular course is having the problem, I need to identify it and I need to address it. So sensitivity is very much required with that particular topic. In a similar fashion, with respect to your software design, if a software behaves in the same manner, whether it should reject in all the particular test case or test conditions that I'll be just giving it, or else it should accept all the test cases or test conditions that I have given to it. So if either of the case is not followed, half the case which will be passed, half the case it will be failed. Means sensitivity is a major issue that is coming under this analysis and testing principles. So that is where it will be counting more. Second one is redundancy. Making intentions explicit. What do you mean by making intentions explicit? A very simple example I'll give you. So we have a software testing principle. So we have a software testing. Testing means what? Testing is whether we are building a product which is giving you the expected output or not. That is the first thing. Second one is either or we can just check out whatever the requirements or specifications that we have taken, whether it meets all the specifications or not, right? So with respect to these two conditions, what I'll do is I'll take one simple project or simple problem statement that has been given by the client. So now in that um, problem statement, I'll identify and I'll just break the entire problem statement into several parts, that is called as modules. Each module, if I test it separately, then we will be applying the unit testing. Unit testing, it may be applied for the entire module or a specific, what you can say, you can apply it for an entire module or a specific function wherever it is necessary, or procedure or a call that has been happened to that will produce the output of that program, whatever it may be. So to a small instance. So like that, n number of modules, n number of unit test cases you need to have it. Once I try to integrate all these modules, then once again it will be tested one after the other. Along with that, how it will be behaving with respect to integration also will be tested. So double time testing happens. Two-time testing happens means you will be achieving the reliability in a much bigger way, or the reliability of the product will be higher when compared to checking for only once. Twice, if it is there, means reliability is more with respect to it. So redundancy gives you a making intentions. It will be explicitly you are expressing the intentions, making sure that your product is double secure. Simple example is your Java or C# program execution or .NET engine execution. .NET runtime engine followed by your um, I'm not saying .NET runtime engine, I'm saying the .NET process program. If you have written in any language that your .NET supports, using that followed by your Java. Both the cases, it will be checked twice. That means first at the compile time, in both the cases, it will be checking and it will be reducing it to the machine equivalent instructions. Once that is done, the next thing is it will be fed to the runtime engine. In the runtime engine, once again, it will be checking for the entire syntax and semantics of that particular programs. So this is twice double checking. So that is what we'll be saying with respect to redundancy. So once it is checked, no, why you need to check it once again? Because it should be compared with respect to the class libraries that has been defined. Based on that, once again, you need to check it with respect to it. So double time checking will give you a reliable product. So that's why we'll be going with Java or C# or any other .NET aware languages. Will be just applying. Next one is restriction. Making the problem very easier. You need to execute all the code in the exe file. It is very clear that you need to go with Windows operating system, that too in that .NET or any other languages, whichever object-oriented language that you are using it. So you need to use it. So life is easy for us. Or else, if you take an example of building one of the product where one web page need to be situated. In that web page, you need to accept some values based on the filters. Filters is very simple. Already, some of the names of the person, name of the student or name of the employee is already recorded in the database. Those databases use whatever the values that has been recorded previously, that should be listed in a sorted order, either in the ascending or descending. That should be decided by the end fellow. So now, with respect to this, ascending order only, if I just ask it to do, then my particular job is over. And in that, specifically, if I just say that you need to use the bubble sort algorithm itself, then it is more specific enough, and we have solved the problem very easily, because there are a lot of sorting techniques available. N number of fellows can think of N number of sorting techniques. Somebody may think that quick sort is very easy, I'll apply it. Somebody may say that merge sort is very easy, so they can apply it. So I need to get a solution for an unsolvable problem. So how to do it? For that, you need to provide the restriction. We call it as rules and regulations. Then we'll come to the generic part. In the generic part, the partition, visibility, and feedback comes into picture. What is this partition is all about? We have already talked about that. So once you arrive at a problem, you just bifurcate the problem into several pieces. So each pieces is nothing but the modules that you are identifying. So based on that, your input will be differing. So based on the input, you just divide the entire problem statement into small pieces. Why small pieces? Because small pieces is easy to understand and easy to implement rather than taking the very huge problem. So that's why cut that particular problem based on the input into several pieces. So each pieces address it separately. Once it is done, combine it and then provide the output. So for providing the output, we need to have a visibility. So whatever the input that will be fed it, after that, whatever the output that it will be for module 1 will be giving, that should be visible enough to the other modules also. If that is not visible, then you cannot run the entire code. So you should be making sure that visibility should be there with respect to any software product that you are accessing to. So it is nothing but accessing the information from one module to another module. That's it, nothing else. So we will be using one of the visibility principles with respect to any program that we'll be writing it. Normally access specifiers will say it. So that is public, private and protected. If you make any of the member as a private, then without that particular class member, you cannot access it outside. So it is better to go with either public or protected. That's what the meaning that they are saying it with respect to visibility. This is a small example with respect to programming language I'm just giving you. So how it works with respect to the entire product, we'll just see it later. Okay, the last one is feedback. This is very important. Okay, I have developed a product, I have run all the test cases, it works fine, it has given me right output, whatever I'm expecting it is up to the mark, and I'm just able to leave to the market. Once I leave the product to the market, it is obvious, first and the foremost thing that I am just expecting is how the product is reachable to the entire end persons that they are using. How better is the solution provided by me is used by end users. That's what I'm just wanted to know. For that, review system is very important. That review system is nothing but the feedback. It helps us in two ways. One is to provide a better output, to provide a better software product in future, followed by any changes need to be adopted while during the testing phase, or during the developmental phase, or during any other particular phase. It helps us to improve ourselves, improve the business standards also. So for that, feedback is must and should. So you need to concentrate on this feedback. So with this, we'll just go to the next slide. Okay, this is a small introduction about all these particular 6 principles. See this sensitivity, I talked about consistency. So consistency is nothing but better, whatever the test selection that you are making it, test input that you are selecting it, that test input should work fine with respect to all the whatever the program that you are having it in, whichever the environment that you run, it should result the same. Best example is your Java programs. Whether it runs in the Linux operating system or Windows operating system, if you have JVM, then it will be giving you the right output. Same output only you'll be getting it always, irrespective of the environment that you are using it. So that is the best example that I can give. This is what consistency is all about. They have given one more example with respect to your deadlock analysis. So normally runtime deadlock analysis works better if it is machine independent. What do you mean by machine independent? That means That's what I just gave an example with respect to Java. So with respect to one particular machine, whatever it is working with respect to this machine, if the machine is allotted a resource from one of the server, if the other machine comes and requests for the same particular resource, then what happens? Until and unless the first machine leaves the resource, it cannot be allocated to the machine 2. So this is your deadlock situation. Nowhere it is. If it is a machine independent, then it is okay. Oh, it has been come from the machine 1. Okay, no problem. If the same particular machine, then once again, if it is having an access to the resource, then you can say that deadlock is available, or you can put a deadlock situation over there. But unfortunately, that doesn't work good in the real time or real world example. So what happens is, whichever the system it comes, so once the resource is allocated for the first time arrival or first uh, user, resources allocated to the one of the user, then it cannot be allocated to the rest of the user. It may be coming from the request, may be coming from the same system or different system or whatever it may be. So you cannot allot any particular thing. So until and unless that process leaves the resources, you cannot allot it to the another system or processors. So this is what your deadlock is all. So that is the consistent one that we are just talking. The next one is redundancy, making intentions explicit. So here there are several points that has been given. Static type checking is redundant with respect to dynamic type checking, but it can reveal many type mismatches earlier and more efficiently. That's what they are saying. So static type checking is nothing but at the compile time you are checking it. Dynamic type checking is at the run time you're checking it. So that's what I said with respect to Java program as well as .NET aware languages. You will be checking the types of variable in two particular cases. One is at the compile time, another one is at the run time. So in both the cases, if you are doing it, it's a redundant one. So once again, you are doing the same thing. Okay, if I give it in a different fashion, say for example, you have a Java program where an integer variable, two variables you are using. So one of the variable is taking an access, taking a value as 10, some another one is taking a value as 20, something. You have a program written for it. Now, you have an object created for the entire class that you have written. So with respect to that object call, you will be just accessing the members A and B. Using that, you are computing some values. Say A is bigger than B or B is bigger than A or something like that. You are just computing. In this particular simple example, you are at the compile time A and B, which is of the particular type, what is the value that has been assigned. So it will be checked for that. Once it is done during the runtime, that is during the object when you are creating it, once again, if you are pointing it to the same variable, that is A and B, with respect to that object reference, once again it will be type checking will be happen. With respect to that, it will give you the output. So twice if you are doing it, multiple times if you are doing it, so efficiency will be more because 2 times you are checking the same particular typecasting or type checking principle. So with respect to that, efficiency will be more. That is what it is meaning with respect to redundancy. Validation of requirement specification is redundant with respect to the validation of the final software. What do you mean by this? Say once you are given a problem statement, you need to record or you need to make the statement into several pieces. That is nothing but you need to record the requirement specifications. Once you have recorded the requirement specifications, you need to validate those requirements. Whether whatever the problem that has been listed, it is covering all the concepts or not. That is the first thing. This should be done manually. Second thing is you need to run, you need to design a particular uh, you need to design a block diagram for the entire requirements that they have given it. So after designing it, you need to write the code and you need to execute it. Once the execution is done, once again you are validating for the entire scenario whether it is matching or not. So requirements during that you are validating. Once again after completing the entire program, once again you are validating. So 2 times it will be done. So you will be revealing more errors earlier and more efficient product you will be getting it at the end. That's what it says. Testing and proof of properties are redundant. Testing is one and the same, and proof of properties is also one and the same. See, testing means what? It is just checking. It is a checking whether it has been fulfilled with respect to all the requirements that has been stated. That's the first step. Second one is it is not only check for the requirement specifications that has been provided. Along with it, whatever the expectation that we are having it with respect to the software program that we have written, whether it meets or not, will be just checked. So both the things will be done. So that is testing. Proof of properties is one and the same. Okay, you have this, whatever the input that I am just giving it, if this input space, if I choose it, whatever the expected output is there, whether it is matching or not, I'm just checking it. So it will increase your confidence to an extent, saying that with respect to both the cases, if you are getting the same output, everything is working fine over there. So redundancy does not make your system to uh, a non-reliable one. Instead of it, it makes your system to a reliable one. Before going to the partition, I'll just try to go through our specific type of analysis and testing principle, that is restriction, the last one. Making the problem easier. That is, making the problem easier in the sense, making an unsolvable problem to a solvable one. How to make that? In two ways you can do it. So they have given two different terminologies over here. One is called as weaker specification, another one is called as stronger specification. What is weaker specification? They have given a simple example with respect to pointers over there. You can just look into that. What do you mean by these pointers and all those? Pointers are nothing but locations where it has been given. The address will be provided. That address you need to take it. If you imagine a Java program without calling a pointer, that is ampersand and all those things, address and the things that to call it, right? Without calling that, yeah, with respect to the object-oriented principle, it will be calling the location by itself. It will calculate its location and it will calculate the entire size of the location. Everything will be done by itself without giving any importance to the user. Once you call it, it will be doing by itself. Automatic way of analyzing or initializing the addresses. So that is done with respect to your Java program. That is what weaker specification is all. Next one is stronger specification. It is based on your type errors. The simple example that I can give you is with respect to your compile time, it may work fine. See, a simple example is with respect to the arrays. In the arrays, what we will be doing is we'll be having the what we'll be having? We'll be having a very simple and very easiest way of analyzing how many elements that we need to have. That is the size of the array. If you have mentioned something, that should be restricted with respect to your array creation. You cannot cross that limit. That is where your size of the array is all about. So once it is compiled, it is fixed. You cannot change it. During the runtime, although you have 20 elements in an array, if you are accessing the 21st element, there should be some error should be mentioned over there. What is that thing? It is saying that yes, you are accessing for 21st element, that is not available according to the array declaration part. So kindly revert back. So this is what the message that I am just printing it over. That can be that need to be handled properly. So that is nothing but here the strong specification part that they have given. So statistically typed languages impose stronger restrictions than that are easily checkable. That's what they are saying. Dynamically typed languages at the runtime, whatever you are checking it, so that will be giving you a lesser restrictions when compared to your statistically statically typed language. Statically typed means that is nothing but at the compile time. Dynamically typed means at the runtime. That's what they are saying. So at the static way itself, if you are just looking into the matter, then it will be easy for us to identify the errors. That's what they're saying it with respect to restriction. Now we'll go with the generic way of analysis and testing principles. First in that is partition. That's what we have just given it over there. Here what they are saying is divide and conquer. We have seen this divide and conquer somewhere in our design and analysis of algorithm. What we'll be doing, a quick sort is a design and divide and conquer principle. Your merge sort is a divide and conquer. What you'll be doing, you'll be entirely whatever the design is that, you'll be dividing that into two or more parts based on what here based on the input space we'll be dividing them. One is called as hard testing, another one is called as verification problems. What is this hard testing? Hard testing is nothing but what manually you'll be doing it. No, you'll be calculating it. No, that is nothing but your hard testing. Hard is nothing but human intervention should be there with respect to that type of testing. That's what they call it. So both structural and functional test case selection criteria identify suitable partitions of code or specifications. Partitions drive the sampling of the input space. That is, whatever the structural and functional test case criteria that we have just seen it with respect to the examples, all those will be containing suitable partitions of code or specifications. That is, we need to identify which part I need to just go with it, how it will be identified and how it will be done. Best example that I can give you is with respect to the path testing. With respect to path testing, we have seen binary search algorithm. In that, the entire program is not taken for analyzing the path testing. What we have done, we have just restricted ourselves to the algorithm where binary search will be done over there. Understanding it. So, with respect to that, we'll be just talking to. So that is nothing but our yeah, that is nothing but the partition and divide and conquer principles. So that is with respect to the hard testing. Whereas verification techniques fold the input space according to specific characteristics, grouping homogeneous data together and determining partitions. What do you mean by this? Verification means what? Are we testing the right product? Verification happens before building the product. Okay, so that is where your verification technique will be available. It folds the input space according to a specific characteristics, grouping homogeneous data. Homogeneous means similar type of data together and determining the partitions. So based on input space, we'll be just dividing it and we'll be just conquering it at the end. That is what it will be done with respect to partition technique or principle. Next one is visibility, judging the status. How to judge the status? So how to say that your integration testing has been passed? So it need to be the data that you are outputting from module 1 should be going to the module 2. So if the data is not visible enough, then how can I judge? How can I give the status of that particular judgment? It is hard for us, right? So just because of it, we need to provide a proper judging status. That is, visibility should be available. The best example that I can give you here is with respect to your Windows operating system and the Linux operating system. With respect to your Windows operating system, you need to go with saying that whatever the members, with respect to your Windows operating system, whatever the things that you are saying it will be restricted enough. Nowhere you can just see what the code behaves, how it will be done, and all those things. Whereas with respect to your Linux operating system, including your system files, everything, they will be giving the rights to change. You can view that, you can change it, you can edit it, you can just execute it, you can just feel the changes. You can build your own operating system, Linux operating system, but you cannot build your own Windows operating system. Whatever the Windows operating system that has been built by uh, Microsoft people, you need to use it. So that is where the challenge comes into picture. Observability, how to choose the input, what is the internal data format that it will be having it. Each one should be seen it separately. That is the visibility. Visibility here is nothing but whatever the data, how the input has been chosen, that input, how it flows. Once it has been come out with respect to one particular module, whatever the output that you are getting it, depending on that, how it behaves with respect to the other module, it need to be taken care of. Without this output, it cannot be fed to the next module. So that is what we call it as with respect to visibility. Judgment needed. Once the judgment is needed, at that time, it should be observable enough, or you need to just have a visible amount of, you need to visualize the data, whatever the data that is flowing, you need to visualize it properly. That is what they mean it with respect to this particular aspect. The next slide is feedback. This is very, very important. After any software product that you just designed, the last step that you need to go with it is feedback or the review system. This review system will help you to develop a better project or a better product in the nearest future, and as well as whatever the mistakes that you committed with respect to designing the software product, it helps us to improve. So that is where you need to have it with respect to your feedback analysis. So feedback is given in all the particular criteria whichever we choose it, or in all the categories whichever we choose it, whether it is an educational based on the course that has been designed to you, based on the lessons that has been taught with respect to each one of the courses, how it was, everything. The review system will be done. If you want to leave that particular part itself. If you just take a small example, nowadays everything is done online. You're purchasing the product also online. So once you are purchasing a product, any product, it may be hardware, it may be a software, it may be anything, you always look into the review of that particular product. What is this review is all about? That is the feedback. Some people say out of 5, 4 plus stars, 4 plus 2 or 4.2 reviews are available with respect to that. So somebody say 4.5, somebody say 5, somebody say out, whatever it may be. So based on this review itself, we will be opting to choose whether the product is working fine or not. Understanding it. So keeping that in our mind, so we need to choose the better product. So this is where it will be giving us, it will be helping us to choose the best reliable product in the market. So this feedback will help a software design or development people to enhance their project reviews. If the project review is good, then they can try to implement in the same fashion where in which the previous product was developed, as well as they may try to enhance it. That may be the case. Or else, if the review was not at all good, no problem at all, we need to change the entire life cycle of the software development process that they have included. So this gives us a complete picture about the product design. So very important to take feedback with respect to whichever the technique that you are using. So I'll just summarize it with respect to this basic principles. So here, the discipline of the test and analysis is categorized into major 6 principles: sensitivity, redundancy, restriction, partition, visibility, and feedback. This is very, very important to know. So we need to just address these particular 6 principles if you just take care about it. So it provides you the which particular product is a better one when compared to the, or which company is producing a better software product when compared to the other company. That's what it will be giving. With this note, I'll just end this particular class. First part of your fourth module is completed. We'll just check out the rest of it in the next class. Thank you very much for your patience listening. We'll stop here. Okay. Thank you.